This website is the Copernicus website. Copernicus is the European Union system for Earth observation and remote sensing. And as you can see, it's useful to study atmosphere, ocean, seas, lands, and climate changes. And in our project, we are interested in climate change. So what we will do is go in and click on climate change. And don't forget, you've got to register. So it's not a difficult process. So before logging it, you've got to register. And after registering, you will get access to huge amount of data that will allow you to make exercises with your pupils and with your students. And after climate change, we are interested in discovering climate change. And since we want to do exercise based on data, we go and click Climate Data Store. After clicking it, we find ourselves in this page, and we absolutely need tools to make graph and to retrieve data. So we click Climate Data Store Toolbox, and we find ourselves in this magic box with easy tools to get data, to get graph, and to study weather and climate, and also air pollution and air quality. What you will do is to click Toolbox Editor, and you will arrive in this page where you will write your easy program, your easy Python program that will allow you to retrieve data and to prepare graphs. So you have this dashboard, this console, and it's divided into three parts. The leftmost part is a sort of working space where you can find all your files and all your job that you run onto the system. In the central area, there is a very easy Python program already written and with minor changes that I will show you. You will write your own data retrieval program. And on the rightmost part of the dashboard, there is the space where you will get your graphs. And here we have our dashboard. And let's have a look at the central part of the dashboard. This is a Python program. You don't need to change it. You don't need to change it massively. What you want to do probably is to define your latitude and your longitude, or at least to define the longitude and latitude you are interested in, the region you want to examine. So if you have a look at these two lines, you see that there is a default value, and this default value is what you want to change into the value, the desired value for your exercise. It shouldn't be that difficult to find latitude and longitude for a region or for a city or for a geographical spot that you are interested in. Another characteristic of this program is that you are allowed to define the variable you want to acquire. So have a look at here. There is a field called variable, and you have variable names. You can find variable names, available variable names in the guide that's in the previous page. And here, just as an example, I chose the temperature at 2 meters above ground, the south-north and east-west components of wind vector, and the mean sea level atmospheric pressure. Then you have to express and to specify the date, maybe a day or maybe many days, or maybe a single days per month, or maybe a single day per month for several years. Anyway, in this structure that's called the CT catalog retrieve, you have plenty of choice. And just to give an example, I chose a single year, 2020, one single month, December, and the days in December starting from December the 1st to December the 10th. And I decided to acquire the data expressed in the variables at 6 o'clock, 8 o'clock, and so 10 o'clock, 12 o'clock, and you can read the time here. Okay, so basically this program is ready to run. I chose to show you an example in days when in Modena we experienced heavy floods. So after saving your program, my program is already saved, so I don't need to save it again, but you will be reminded to save what you wrote, and you will find your program here in your working space. I was saying after saving it, you can run it. So you click on the run button, and you have to wait a little bit. Today the servers are not very busy, and what you get here is a graph of the temperatures that were recorded in the days that I asked here, which means December the 1st, the 2nd, and so on and so forth until December the 10th, 2020. And as you can see, it's a pattern that shows you a peak in temperature in 2 meters. What you might want to do is go full screen. So if you reach this right arrow here, you click on it, and another window will open for you showing you the temperature, but you can go here and you can choose amongst the variable that you asked to retrieve, and so you can have a look at the atmospheric pressure. Of course, the servers need a little bit, but they will present you a graph plotted according to the data that you asked. So the analysis, we have an easy analysis of those days, because as you can see, at the early December we had a high atmospheric pressure, sea level. We had like 1015 millibar or hectopascal if you want to go with the international system. And in 3-4 days the atmospheric pressure dropped and decreased dramatically until December the 6th, when we recorded 997, which for my region means heavy rains. Okay, and if we have a look at the temperature on December the 6th, approximately December the 5th, December the 6th, you see that the temperature had an opposite variation. We went from December the 3rd, we had 4°.72, and in a couple of days we reached 14 degrees, which means that a strong wind was blowing from south, so we can even get a view about the wind. This is the component, the U component of the wind. It takes a little bit to retrieve data if the servers are busy. But at the end of the day, you will have, as you can see, these data about the U component of the wind and the V component of the wind. So it's just a matter of waiting a little bit, and then we will be able to have a look at the other component of the wind. Okay, and as you can see here, this is the south to north wind. So you see the peak of the wind, it's northward, which means that it's south to north, and this means that a strong warm wind was blowing in our region. This means that on December we had already snow in the mountains, and the snow probably melted down, and the floods we had in those days were partially caused from the rain and partially caused by the wind, the warm wind that melt the snow. So finally, again, we can have a look back to the temperature, and you see the peak in temperature approximately December the 5th. We can have a look at the atmospheric pressure, and you see how heavy was the fall in atmospheric pressure, and the south-north wind direction, and you see there is a peak in the same day. On December the 5th and December the 6th, 2020, in Modena, we experienced heavy floods also in the surrounding area due to caused by the melted snow on the mountains and caused by the rain.